All right, here's an example similar to problem 5.5.33 on your homework. And the problem says evaluate the integral. Right, that's really all we're doing right now. Evaluate the integral, and then it gives you an indefinite integral, so one without bounds, of 5 over t to the sixth times sine of 1 over t to the fifth minus 4 dt. Okay, so this is pretty clearly going to be a u substitution problem, right? The reason that I can recognize that is that, well, first off, there's no easy way to integrate this. And second off, there's a relationship between this here and that there. If I take the derivative of this term, it's going to turn into the negative of this term, right? So that means there should be some sort of u substitution going on. And this 4 is just going to go away when I take a derivative. So I'm going to do a u substitution, and I'm going to set u equal to 1 over t to the fifth minus 4. Then du is going to become, right, so I multiply the power down, so that's negative 5, and then I subtract 1 from the power. It's going to become over t to the sixth. And the 4 goes away because that's a constant, dt. Well, that's exactly what I have over here if I associate this with this dt, and I just bring a minus sign out front, right? So I'm going to bring a minus here, minus there, associate this term with the dt, and then that's just going to turn into du. All right, so what does this turn into? It's negative integral sine of u du. Right, and now I'm just going to take an antiderivative. What is the antiderivative of negative sine? Well, it's just cosine, right? Because take a derivative of cosine and you get negative sine, so the antiderivative of negative sine is cosine. And then last but not least, add the plus c and substitute in what u originally was. So cosine of 1 over t to the fifth minus 4 plus c. And that is your answer.